There is a quiet fear that belongs to modern learning. You arrive in a field where everyone seems to be speaking quickly, using confident jargon, and moving on before anything has been properly explained. You feel swallowed up by a demand for instant mastery. This pressure creates a fog. In an effort to keep up, a confused mind often tries to look impressive, adopting advanced language before it has actually seen the basic truth beneath the problem. This is the mansion of ego. It's a state where learners memorize clever phrases and guess silently to protect their image. It is the fear of arriving in a room where you are the only one who doesn't understand. When a mind is focused on defending its identity, it loses its ability to notice evidence. True learning is paralyzed until the pressure for performance is dismantled. The first step out of that fog is the first principle of nothing.
It's the radical act of stopping the race entirely and attempting to solve the problem without a computer first. As this diagram shows, internal calm is a prerequisite for structure. The body speaks through heat, tightness, or restlessness before the mind processes logic. These signals must be quieted to move from emotional awareness to a structured problem-solving grid. With a quiet mind, you can start from what is true. You look carefully at the problem, name the essential parts, and divide the complexity until the pieces are small enough to handle without shame. Deep learning requires this patient architecture. It replaces the panic of getting it right with a deliberate method of noticing and naming. Before reaching for code, the mind creates a portable sketch, like a drawing of a cup that captures the curve and the handle while ignoring the molecules. This sketch keeps only the structure that is useful for the task. Human logic relies on a repeatable circuit. Notice a real-world relationship, divide its complexity into manageable chunks, and test a single small example to see if the logic holds. Digital embeddings, the way a machine sees data, are simply automated versions of this sketching process. They convert rich, messy information into a structured internal form that a model can use. This human logic blueprint must come first. You cannot build a stable machine until you understand the simplified representation the mind uses to meet difficulty. Advanced mathematics is often presented as a wall of symbols designed to exclude the uninitiated. In reality, these symbols are shorthand for the logical relationships we have already identified. This panel illustrates vectors, our lists of numbers organizing information, providing direction and magnitude to turn abstract data into readable locations. Moving to the orange panel, matrices transform those organized lists, applying a rule to reshape input data into a useful form. Even calculus follows this common sense. Gradients and backpropagation are just methods for gathering local messages about mistakes. They measure the gap between the target and the actual result to guide the next small adjustment. When math is viewed as a sequence of honest adjustments rather than a test of brilliance, equations lose their power to create panic. They become lanterns instead of walls. Modern AI systems are built by stacking these small mathematical truths. Transformers and neural networks take these simple layers of vectors and matrices and pile them together to handle increasingly complex patterns. We scale this logic further through multi-agent systems. This architecture mimics how we avoid overwhelm in our own work by partitioning our attention and assigning specific jobs to different parts of a team. Each agent has a narrow focus. One part notices the incoming terms, another collects the relevant data, and a third checks for errors. By stacking these layers of job-specific agents on top of our foundational math, we create a system capable of executing partitioned logic at an automated scale. This image of a human climbing toward a digital brain represents the final layer of the journey. The lesson of AI is not that a single autonomous agent can replace human thought. As systems become more capable, the need for the human override increases. Every tool eventually touches a real-world consequence, and that is where the builder must stay awake to govern the outcome. A model produces a description, a prediction based on patterns it has seen, but only a human can evaluate that description for fairness, truth, and fit within the real world. The peak of this ladder is the capacity for independent judgment. Proficiency in coding is a tool, but responsibility is the goal. When a new technical term appears, it no longer acts as an obstacle. The learner now has a method of return. Identify the name, ask for the need it solves, and break the symbol down into the relationship it is trying to compress. A machine can calculate a gradient or adjust a weight with perfect precision, but it cannot feel the weight of its own decisions. It processes signals without comprehending the lives they represent. It is this gap between calculation and comprehension that reveals the core truth. Intelligence is not the same thing as understanding. The book is closed, but the logic is open. You have the blueprints and the tools. The ladder of intelligence never ends. Keep climbing.